Hello everyone, hope you are doing good and welcome back to my channel. Today we are at day 27 of the October Daily Leetcode Challenge and we have a very good question in front of us. It's a medium level question. For the past few days we were having questions related to graphs, trees, but today we have a slightly different question and it's related to matrix and we are again back to the matrix tree. So in this particular question, you will get to know see you will also learn about the traversals, but here it is more to do with the dynamic programming and also about how quickly you are able to understand the pattern here. If you get the pattern, this question will be very easy for you to solve. Let me tell you, within a minute you will be able to code it, but we'll have to catch that pattern first. So it's all about that pattern. That is the main focus of this problem. Matrix wise, if you are you know how to traverse a matrix or basic traversal algorithms, you know it, or you're even aware of what a DP is. If you're aware of DP, obviously you'll be knowing matrix is very popular. Matrix question very popular when we talk of DP. Okay, so this is one such question. Now coming to this particular question, what is given to us is given a m into a matrix of ones and zeros. So it's basically all the elements are going to be within 1 and 0. That is binary. Written how many squares a matrix have all ones. So, okay, so let us quickly see the examples. So what they are trying to tell here is that you have a matrix and see the given matrix need not be a square first of all. Okay, it can have different, the length and the width can be different. So here you can see there are zeros and ones present. What they're trying to say is you will have to calculate how many squares of matrix are there which have all ones. Okay, that is a square form should have all ones. So what they're trying to say is see individually each one of them is a square matrix in itself, square sub matrix in itself. Okay, so how many ones are there, that means square sub matrix we are going to have it, that is 10 in this case. Okay, there are 10 ones in this particular matrix. If you count here, okay, in the first row you have 3, in the second row you have 4, in the third row you have again 3. So 3 plus 3 plus 4. Okay, you're going to get 10. So the number of ones is basically a number of sub matrix of length 1. Okay, which is 10 in this case. Next, coming to the number of submatrix of length 2. So which are they? So if you see here, if I take these two ones and if I take these two ones, this together will form a submatrix of length 2. Okay, so that is one again. Okay, and the same is the case here. If I take these two and if I take these two, again they will form a submatrix of length 2. Same is the case here. See, if I take them these two ones and the ones below them, okay, again they will form a submatrix of length 2. And same is the case here. If I take these two ones, okay, and the ones below them, okay, you will again get a submatrix. So total we are getting 4 submatrix of length 2. Okay, that is what is mentioned here. Okay, now coming to a submatrix of sub square matrix of length 3. Okay, if you see here, this if you take and all the ones below them as well, okay, this one and this one, you are getting a square. Okay, all of them are having ones and the length is going to be 3. So there is only one sub square matrix of length 3. Okay, so if you add 10 plus 4 plus 1, you're going to get the answer which is 15 in this particular case. This is what the question is. So what you have to do, first of all you have to find out the squares which are found with ones. Okay, squares forming with which have only ones present in them. Okay, and then you have to count all of them. Okay, so basically when you're saying square, they're basically we are referring to a submatrix. Okay, that is a matrix within the given matrix. Okay, submatrix. uh, uh, for this particular question, just for your easiness, I can call it a sub square. Okay, because within the matrix I am going to form a square, so you can also call it as a sub square. Okay, so basically 15 is the number of subsquares. And one thing you have to remember is that even a single element, okay, is counted as a square of length 1. Okay, that is also important here. Similarly, they have given one more example. They have given the calculations. You can go through it on your own. Okay, I am not going to take much time here. Just jumping to the constraints here. Some constraints are going to be important because to decide on the time complexity, I can say that to give you idea of the time complexity, this is going to play a major role. Okay, so here they are saying that is length of array. See, whenever I say length of array, it basically means how many rows are going to be there. Okay, how many rows are going to be there? It's going to be 300. Similarly, number of columns is also going to be 300. I hope you are correctly interpreting them. This is the number of rows and this is the number of columns. Okay, so it is going to be 300 and 300. So the total, the highest, that is the biggest matrix that we can have in this particular question is 300 into 300. So this also tells me that here we can compromise on the complexity. Okay, because see, here it is not like 10 raised to power 5 or something like that. Okay, here it's not the case. So you can have a solution which is slightly bigger in terms of time complexity at least. Okay, but again, in terms of time complexity only, not in terms of space complexity. You should not be crossing too much of space. That is 300. See, whatever is the length given, okay, whatever is the size of this particular matrix given to you, you can maybe like form a solution using the same space again. Okay, that is forming a matrix of the same length again, but not more than that. But yeah, you can go up to a bit farther compared to the time complexity. Okay, That is the first thing. Now coming to the solution. See, solution is going to be very easy, but like as I told you in the starting itself, it's all about how you're finding that pattern. Okay, that pattern is going to be more important here and not the actual solution. Okay, so coming to the full screen mode. So see here, like this is the matrix given to us. Okay, and I am talking about, see, as I mentioned, I am going to solve this problem using the DP approach. Okay, DP is basically the dynamic programming approach, and whenever you are learning about DP, you will always get a lot of questions related to matrix, and this is one such question. Okay, so this is how my DP will look. I will like form this from scratch and show you how it works. But for now, this is going to be my input. Okay, I will quickly tell you how all these things is coming. Let me delete first. Okay, so what I'm going to do, see, this is my matrix here. All are one. Just for a simple, to show you how it works, I made it all one so that we can have a lot of squares so that I can show you how it works. Okay, so what we are going to do, see, it's going to be very simple. This is the matrix given to us. Okay, now if a particular element is one, okay, if a particular element, see, what I'm going to do for each element of the matrix, I'm going to find out a element for my DP array. Okay, for example, for this particular element, I'm going to find what is will be the value of my in my DP array. Okay, so what I'm having, so if the element is one, okay, in the matrix itself, then I'm going to use some, but I can say it a pattern, or you can also call it as a trick. Okay, I'm going to do that. In other case, that is if the element is not one in the matrix, I am going to leave it as it is. Okay, this one thing is very, very clear. Okay, so what is that? I will tell you. First of all, what we have to do is, see, one thing. Okay, one more thing is DP. What is basically, see, whenever you are defining a DP, you will have to devise a particular methodology behind it. So in my case, what is DP of I of j going to be? See, DP of I of j in this case is going to be the number of all squares which are going to end at matrix of ing. Okay, what is dp of ing? It is the number of all squares. When I say all square, it means any number of length it can have. For example, it can be of length 1, it can have length 2, it can have length 8, more such like that. Okay, so total number of squares which are going to end at I comma j index. Okay, that is going to be dp of I comma j. Okay, so this is the matrix given us. Now how to form the dp? First of all, when we talk about the border elements, that is the first row and the first column. Okay, you'll have to write them as it is. Okay, just write them as it is. Fine, I'm writing them as it is. Okay, the first row and the first column, I'm going to write them as it is. Now from this particular element onwards, the calculation starts. So what I'm going to do, see, I am at this particular element, right? Yeah, so what I have to do, take the element to the left of it. Okay, take the element to the left of it, that is this particular element. Take the element to the, that is the element above it. Okay, and take the element which is diagonally left and top of it. Okay, that is this particular element. So what you have to do, for any element, take its left element, take the element which is above that, and take the element which is diagonally left to top of that element. Okay, so for this middle element, what are they? Okay, for this particular middle element, okay, these two elements and this one element. Okay, I'm going to take all three of them. Okay, what I have to do, calculate the minimum of them. Okay, and add one to it. Okay, as simple as that. So in this particular case, what it will be, can you quickly tell me? It will be minimum of 1 comma 1 comma 1 plus 2. That is minimum of 1 comma 1 comma 1 plus 1, which will be 1 plus 1, which is 2 in this case. Okay, as simple as that. Now can you tell me for this particular element what it will be? Again, it is surrounded by all ones. Okay, the left element, the top element, and the element which is diagonally left and top of it. Okay, what it will be, it will all are ones, so it will be minimum of 1 comma 1 comma 1 plus 1. Again, it will be 2. Okay, now coming to this particular thing, the same for here also, it is surrounded by all ones, so here also it will be 2 coming. But yeah, the last element is, it's very important here, so please pay attention in this case. So what is happening is, if you see here, basically, yeah, so here I have twos. Okay, so this particular element, if you see in the, see, I'm talking about this element, but you have to refer it in terms of the elements in the DP array. So here it is surrounded by twos, so what you have to do, minimum of 2 comma 2 comma 2 plus 1, which will be 3 in this particular case. Okay, that is how I'm going to form the DP array. Now what will be my answer? My answer will be sum of all the elements of the DP array. Okay, so what I'm going to get, that is number of ones. How many ones are there? There are ones in the first row and in the first column also, so it will be total of 1 plus 1. Okay, it is 5 as such. Okay, now number of twos here. Okay, if you see here, there are 3 twos, which is 6 in this case. Okay, then final we have a 3 in this case. Okay, so what is the answer going to be? 6 plus 3, which is 9, plus 5, which is going to be 14. Okay, that is going to be the answer. I have also formed a test case out of it. Okay, I will show you the same while running the test case. So what I'm going to do, see, first thing is, you have to take the first row and the first column as it is from the matrix array, and you have to paste that as it is, okay, in the DP array. For rest of the them, you have to use this particular algorithm, okay. And if you tell me how this algorithm comes, see, it's all about observation. In If this question comes in a real interview, let me tell you that they will definitely be giving you some, ideas, at least some help they will be giving you to form this particular thing, okay. They will be like telling you, see, DP, when I talk about, see, DP is all about how you're imagining it, okay. This particular thing here, you have to get this, otherwise you will not be able to get in this particular time complexity, okay. The time complexity in which I am solving it, okay, it is going to O of m into n, that is m means the length, okay, O of length and breadth of the matrix, okay, length into breadth of the matrix. In this particular time complexity you have to solve, you have to know this particular, you know idea. How to get this idea? See, in the interview of this comes, first of all, you have to solve it using a brute force approach. Once you solve it using a brute force approach, then the interview will try to push you toward this idea. Okay, they will see what will happen is they will tell you, okay, what you have to consider, you know, all the, for example, if I am at a particular index, how many squares are going to end at that particular index, okay. They will give you this particular idea, and then you have to slowly come to this particular solution, okay. Don't worry, they will be, giving all the hints required to come to the solution. Remember, coding interview is all about, once you are given a slight of the idea, okay, slight hint of the idea, you should be able to code the solution. That's what it is, okay. So if this thing is given to you in some of the online coding interviews, what happens is that you will be given this as it is, okay. You will be given this as it is, but you will not be given that even the first one, the first column, you should not be applying this, okay. At least this will not be given to that, okay. This particular thing will be given, but you will not be given that this thing should not be applied in the first one, the first column. That is another way of giving that, okay. That is in the online assessment, but in a live interview, that is a face-to-face interview, they will be giving you hints and you have to come to this particular idea. But obviously, to start with, you have to do it in a brute force approach only. Then if time remains and if they are really interested to go further on it, then you have to come to this particular solution, okay. So I have told you how the DP array is formed, and by the way, what is DP I of j, also I have told you that DP of I of j is the number of squares, okay, of any length which are going to end at I comma j index, okay, as simple as that. Now coming to the solution. See, you can see, as you have seen, we are forming a different DP array to solve it. But in my original solution, what I've done is, in the matrix itself, I've done the manipulation, and so that at last, when I'm at the end of the problem, my matrix itself will be converted to a DP array. Okay, so the elements of my matrix will be converted to the DP array, and then I'm getting the answer. That is, I'm not using any extra space to get my answer. I will show you that quickly. Let me comment this part. Okay, now coming to my this particular thing. Okay, let me quickly run this once and show you, because the test case which I have shown you here is, I have added that separately here. As you can see, this is the test case which I have shown you currently, the dry run of this, and the answer is coming as 14, which I have shown you. Okay, now coming to my solution, what I'm doing is, here, see, matrix is as it is given to me, okay. I have printed this initially. At last, when I'm printing it, it is no more matrix but my DP, okay, as simple as that. And whenever I've declared answer variable, whenever I'm calculating a DP of I of j, I'm also adding it to my answer, okay. And finally, I'm writing that answer. Now what is happening? As simple as that, first one, the first column should be as it is. That's what I'm doing it here. If r equal to 0 and c equal to 0, what are r and c? R basically refers to the row, okay, row index, and c refers to the column index, okay. Whenever they are, any of them is 0, that means we are either in the first element or in the first column element. Whenever they are 0, you don't have to do anything, simply pass over, okay. In the else condition, I'm including another if. That else if matrix of r of c is equal to 1, that is only when the element is 1, okay. First of all, it should not be in the first or the first column. Other than that, if it is 1, what you have to do, the same thing here. You have to take the minimum of the left element, minimum of left element, okay, top element, and the diagonally left to top of element, left to top of that element, okay, diagonally left slash top of that element, okay. So what you have to do, minimum of left element, top element, and the diagonal element, which is, you can say left and top of it, okay, left of it and top of it. You have to take that and you have to add 1. See, why we are adding 1? Remember, whenever a matrix value is 1, it itself in itself is a square, okay. That's why, other than this, even if this comes to be 0, still you have to add 1, okay, because we are also considering squares of length 1. So the element in itself is a sub matrix, it is subsquare of length 1. So I'm adding 1 to it, okay. Once it is done, what you have to do, see, once it is done, we will be will be coming out of this if and else conditions, okay. Finally, you have to add answer to the this particular element, which is currently DP of I of j, should be added to the answer. Remember, if it is not 1, then by default it will be 0 only. That means 0 will be added to the answer, which is fine, okay, as simple as that. And finally, I'm returning it. This is the second time I'm printing the matrix, just to show that it is now converted to the DP array. So let me quickly run this. Yeah, so this is how my matrix is looking. but at the second time when I'm printing it, it's basically my DP array. Okay, so this exact you know test case I've shown you in my dry run, and these are the two inbuilt test cases which you'll be getting when you are opening this problem for the first time. Okay, this is the DP of that, and similarly for the first example, this is the DP of that. Okay, yeah, this particular example. Okay, as you can see, the side 3, that is square of side 3, there is only one. As you can see here there are side 3 is only one. That is, for this particular element there are 3 squares which are ending it here. Okay, as simple as that. So yeah, friend, that is all about this particular question. And because, yeah, now coming to space and time complexity of it. So that here there is important thing. See, in my case, what I've done is that I am not using any extra space. Okay, when I say about space complexity within the given matrix, I'm making the changes. So in my case, it is O of one space complexity. That is O of constant. Okay, that is O of constant space complexity. Okay, this is the space complexity. Now coming to the time complexity here. See, just try to understand what we are doing here. Simply, we are going through each of the elements. Okay, we are not doing any additional processing here. Simply, we are going through each of the elements. To go through each of the elements in a matrix, okay, then in a two-dimensional matrix, how much time it will take? It will take O of n square time, where n is the length. Okay, but here it is not a perfect square. So in this particular case, it will O of m into n. Okay, what are m and n in this case? M and n are basically the length of rows and columns. Okay, that is the width and height of the matrix. Okay, this is going to be the time complexity. Here we are simply, traversing that, I'm simply passing through each element. I am, see, calculations is being done, but time complexity refers to like when the number of elements increases. Okay, how much time it will be consuming. So in terms of that, it is O of m into n. Okay, so yeah, this particular thing is important because this you can do it in this particular problem. It will not be always possible, but yeah, in this case, since you are returning just answer, okay, I am modifying the given input itself as it is, because yeah. But yeah, in a online assessment, you should be careful when we are going to make changes in the given input itself. You should be careful because sometimes that is also checked. If that is not matching, your case may be rejected. Your test case, that is your solution, may be rejected for a particular test case. Okay, so just be careful in that before submitting an actual solution. Try to run your solution on some of the test cases, your own design test cases, and see if that works. Only then go for such solution. Okay, before that it should not be. So this you should be careful about. Other than this, yeah, everything seems good here. Okay, finally I'm writing the answer. As you can see, whenever a matrix is calculated, I'm adding it to my answer. Okay, even if it is zero, you can add a zero. It's fine, as you know. Okay, adding zero will not change it. And finally I'm writing the answer. Okay, I've already segmented the solution and it works. I will give the same solution in the comment section. You can go through it. Yeah, the only this part is important. And remember, friends, I am not going to in okay, there are so many solutions given in this particular question. You can go through them, but remember one thing: how to commit this ideology. See, just by reading this question, you will not be getting this. That is the first thing you have to understand. Okay, in this kind of questions, whenever they come, okay, there will be some hints available. Okay, there will be some hints available. You have to build on those hints. Okay, that is how the interview will be. Okay, but remember one thing: whenever such a question comes, always try the brute force approach first. Okay, you should. Let me tell you this very frankly: you will never be able to get this kind of solutions in your first approach. You should always be starting with the brute force approach. Then the interview will give you some of the hints, and then based on those hints, you will have to find the solution. As simple as that. You may not be feeling like I am saying the right thing, but believe me, I have gone through a very high number of interviews. Okay, and this is the reality. Okay, whenever you see such a question, do not think that it will come as it is. Okay, in an interview, if that comes, that is not the right way to test a candidate's professions in coding. Okay, as simple as that. These kind of things, they will test your knowledge, they will test your observation, they will give you some hints, and they will see whether you are able to form above that or not, whether you are able to continue that logic or not for some more time and get through the real answer. Okay, as simple as that. Fine, yeah, as it, and this solution is based on the DP approach because uh, through one element we are trying to find the other elements. Okay, through one part of the answer, that is, I am solving a particular sub problem, and based on that sub problem I'm getting the answer to the other sub problems. I am using that approach. That's why it is a DP approach. And yeah, friend, that was all for today. If you like my video, please consider subscribing to my channel. That really gives a lot of motivation. That's all for today. You can check out my past videos which were related to graph, and there were some good questions and graphs entries for the past few days. You can check that as well. Thanks a lot. See you tomorrow.